Alright guys, we're going to be solving the first question from the third chapter of the engineering mechanics dynamics. And in this one we have a swing right. As we can see in the figure, we need to calculate the necessary angular velocity W for the swings to assume the angle of 35 degrees with vertical, so the theta in the question, will be at a point that the swing will kind of be in equilibrium condition at the angle of 35 degrees. And the question is saying that we can neglect the mass of the cables and we're going to treat the chair and the person as one single particle. So we're going to start with the free body diagram of this person and the chair in here. And if we just call one x and y in here, let's call this our x and this will be our y. So let's start with all the forces that we have. So we're gonna have the tension in the cable, and since we are considering the whole thing one single particle, let's just consider one force T, which is the tension in the cable in here. And obviously we have the mass of this chair and the person, or we call it W, which would be mass times acceleration of gravity. And we're gonna have our inertial force, we can show it with Fi, which would be m times r, and angular velocity to the power of 2. So that's pretty much all the forces that we have. And also we know this angle is our theta, which was 35 degrees. And we're gonna try to keep this angle at 35, which means we won't have any move in x direction and any move in y direction. So we can start with sum of all forces in x equals 0, and we're going to have the same thing for y. So if we look at x direction, we're going to have our Fi, which is mr angular velocity to the power of 2 minus the x component of the tension in the cable, which would be this force, and this will be our y. So that would be t sine of 35, the x component, and y component would be t cosine of 35 degrees. So basically we just try to resolve t into both x and y direction. So we're gonna have minus t sine of 35 degrees, and from here t sine of 35 degrees will be equal to mr w squared. And if we want to look at our forces in y direction, we're going to have t cosine of 35 degrees minus our w, which is mass times acceleration of gravity, equals 0. And here t cosine of 35 degrees will be equal to mg. And now we have two equations. You can call this one 1, this one 2. And if we just divide equation 1 by equation 2, we can get rid of t, because we're going to have t sine of 35 degrees over t cosine of 35 degrees. And here we're going to have m times r times angular velocity, which is what we're trying to figure out. And here we're going to have m times g. So as we can see, we can cancel out the m. And the question is, what's our r? So the angular velocity is obviously, we can see it in the figure too, is this angular velocity at a center of this swing right. And our r that we have in here, that is our force, would be the distance from here, or we can show it in here too, to the center of the mass. But since we are considering the person and the chair all in one particle, this would be our r. And we just have to figure this out. And that's not complicated too, because we have this distance in the question 3.2, and we just have to figure out this little distance. And if we look at this right triangle that I'm highlighting in green, since we know this angle is theta, it's pretty easy to find the opposite side of that triangle. We know the length of that cable is also 5, so we're going to have 5 sine of theta, which is 35 degrees. So that would be our r. So we're just going to put that in here. we basically have 3.2 plus this. So 3.2 plus 5 sine of 35 degrees divided by our G, which is 9.81. All of our units are based on meters, so this would be 9.81 meter per square second. And on the left side, we can get rid of t. So we're going to end up with sine of 35 over cosine of 35, which will be the tangent of 35 degrees. And I forgot to put our angular velocity in here. So we're going to have 3.2 plus 5 sine of 35 degrees over 9.81 times. So now we have 9.81, just cross multiply this. We should be able to find our angular velocity. We just have to do the square root of what we found in the previous step. And let's see what we get. So the square root of 9.81 times tangent of 35 divided by 3.2 plus 5 sine of 35. So yeah, that's going to give us our angular velocity 1.06, actually 4 if we want to go one more digit, and that's going to be in radian per second. Whenever we use all of these formulas, what we're going to get for angular velocity is always based on radian, and even if we have the angular velocity based on degrees, we have to convert that degrees to radian, and it's pretty easy. If we want to, let's say we have 60 degrees, we just have to pi over 180, and that's going to give us pi over 3, and we have to use this as our angular velocity. So keep in mind that everything needs to be in radian. And yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.